Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello teacher, hello students. Welcome to a new unit of lessons. We will be learning all about plane geometry, also called Euclidean geometry. This includes triangle theory, circle theory, and special quadrilaterals. We have a lot to look forward to. So if you are ready, let us get started. Why do we study geometry, students? There are several reasons. Geometry can teach us to think clearly. Of all the subjects that you learn in school, geometry teaches some of the best techniques for forming accurate and correct conclusions. Geometry also has a great deal of practical value. Many professions use geometry every day. If you do not learn your geometry, you will be closing off a large number of career options when you get older. Euclidean geometry is among the oldest sciences in the world. The measurement of objects and space and their relationships grew into the discipline that we know as geometry. The invention of geometry was one of the first clues that humans could come to understand the world around them. It is a fascinating discipline, is it not? Let us begin this unit by studying one of the most basic concepts in Euclidean geometry, called the polygon. We have already learned that a polygon is a geometric figure with at least 3 sides. 3 or more points that share the same line are called collinear points. 3 or more lines that share a common point are called concurrent lines. A theorem about concurrent points or collinear lines is called an incidence theorem. We all remember that a line that divides an angle into 2 congruent angles is called an angle bisector. When an angle bisector forms a right angle with the line segment, we call it a perpendicular bisector. When a line is drawn from a triangle's vertex to the midpoint of the opposite side, we call it a median. We will use these terms now, students, to prove some basic geometric facts. Please copy down this triangle carefully and mark the vertices as A, B, and C. Let us mark down the medians of each side. you will find that all of the medians you make cross at a point. We will call this point O. Now, let us measure each segment together. First, we measure segment AO, then OE, then CD. Then, we measure segments OD, BO, and OF. What do we notice about the relationships between these different lengths? Segment AE is 2/3 of the length of segment AO. AE is 1/3 the length of OE. Therefore, the ratio of AO to OE is 2:1. Segment CO is 2/3 of the length of segment CD. OD is 1/3 the length of CD. Therefore, the ratio of CO to OD is 2:1. I am confident that you can now predict the ratio of BO to OF, students. BF is 2/3 of BO, and BF is 1/3 of OF. Therefore, the ratio of BO to OF is 2:1. We have discovered a geometric proof, students. We have found out that the medians of a triangle are concurrent at a point 2/3 of the distance from each vertex at the midpoint of the opposite side. Great work! Let us apply this principle now, students. Here is another triangle. Applying the theorem that we have just learned, find out the length of each line segment.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Here is the mathematical relationship between each line segment. Remembering this property of triangles will make this exercise simple. We know that AO is 12. Since that is equal to 2/3 of AE, AE is equal to 18. OE is equal to 1/3 of 18, which is 6. We know that CO is 6. Since that is equal to 2/3 of CD, CD is equal to 9. OD is equal to 1/3 of 9, which is 3. We know that BO is 10. Since that is equal to 2/3 of BF, BF is equal to 15. OF is equal to 1/3 of 15, which is 5. We have discovered our answers, students. Were you able to find the solutions on your own? If so, very well done. The best thing about geometry is that once we find something to be true for a specific kind of shape, it will always be true. What we have learned about triangles is true of all triangles, everywhere, forever. Try it for yourself, students. Take a moment to copy down this triangle. We will say that line AN is 24 centimeters. Line OM is 10 centimeters. And line BO is 12 centimeters. I am going to ask you to find the length of 3 other lines, students. Use the theorem we have learned to help you. Please get started.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Once again, welcome back, students. I hope you have managed to use the theorem correctly. If you did, you concluded that line BO is 2/3 of line BL. You also found that line AO is 2/3 of line AN. It is simple now to use the values that we already know to discover the ones we don't. If 2/3 of line BL is equal to 12, then the whole line must be equal to 18. If line AO is equal to 2/3 of 24, it must be equal to 16. Since BL minus BO equals 18 minus 12, line OL must be 6. And since AN minus AO equals 24 minus 16, line ON must be 8. If you did this, you have used the theorem properly to produce these answers. Very good. The point of intersection of the medians of a triangle is called the centroid of a triangle. Today, we have learned that the medians of a triangle are concurrent at a point 2/3 of the distance from each vertex at the midpoint of the opposite side. That is all for today's lesson. Next time, we will learn about the altitudes of triangles. Until then, thank you, teacher. Thank you, students.